Okay, we're on the exam review 14b now, and if I look at the absolute value of 4x minus 4 is less than negative 24, hopefully right away you recognize that we have an absolute value, which of course is never going to be negative, less than a negative number. So is it possible for the absolute value of 4x minus 4 to end up a number smaller than negative 24? Well, of course it isn't, because an absolute value can't be a negative number. So that tells me right away that I don't have any work to do. There is no solution to this. Okay, the next one, I have the absolute value of x minus 4 minus 6 is greater than negative 1. Remember, we have to have our absolute value isolated, so the first thing I want to do here is add 6 to both sides, because I'm trying to get my absolute value alone. And that gives me the absolute value of x minus 4 is greater than 5. Now, we know that the absolute value has to be positive, but does it have to be greater than 5? Of course not. So I do have both cases to work here. I do have to solve for this one. So I'm going to start with case 1. And remember, this is a greater than problem, not a less than problem. So it's going to be greater is an or problem. And that means when I'm looking for my solution, it can be an answer to either case 1 or to case 2. Doesn't have to be a solution to both of them at the same time like A did, and that's the reason I was able to write that as one combined inequality instead of two cases. So my first case is always exactly what's in the absolute value sign without the absolute value signs there, and exactly the signs I already had. So I am solving x minus 4 is greater than 5. I add 4 to both sides, and of course I have x is greater than 9. Or, for my second case, I have what's in the absolute value signs, change the direction of my inequality, change the sign of my number. That's because I was saying this was originally negative, so I'm taking the negative across the inequality, and that changes the direction of my sign, the direction of my inequality, and changes my sign. So I'm going to add 4 to both sides, and I have x is less than negative 1. So when I go to graph that, my 2 critical points for my graph, and I'm okay if you just graph your critical points on here and don't graph the entire graph. All the ticks on the number line, I mean. Okay, I have x is greater than 9, which would look like that, and I have x is less than negative 1. Whoops, I wrote negative 4, didn't I? I meant to write negative 1. That's going to be a 1 instead of a 4. My mistake. Okay, less than negative 1 would look like this. And because it's or, it means the answer can be over here, or else it can be over here. It doesn't have to be both places at the same time. It's not an and problem. So I bring everything down to my number line, and there's my solution. And when I go to write my solution in interval notation, which the instructions asked me to do, I start at the leftmost point of my graph, which is negative infinity, and I go to the first point here, negative 1. Negative 1 is not included, so I write parentheses. I know that because my original sign did not have an equal to. And of course, infinity never has an equal sign next to it. And that unions with 9 to infinity. Again, 9 was not included, and infinity doesn't have an included endpoint, so that's the solution for 14C. Okay, on 15A, I am graphing a system of linear inequalities, and the first thing I want to do is look at what I need to know to actually graph those lines. And of course, what I need to graph a line is the slope and the y-intercept, and fortunately for us, these are already in slope-intercept form, so my slope for this first one is 1, and I'm going to put it over 1 since we're using this for graphing, and my y-intercept, which we call b, is 2. for the second one, oops, I said they were in slope-intercept form, and actually the second one here is not in slope-intercept form. So that's the first thing I'm going to do. I'm going to change it to slope-intercept form, which would be negative x plus 5. So now my slope is negative 1 over 1. Again, that's a rise and a run, so I put it in fraction form. And my y-intercept is 5. So I'm going to draw myself a graph. Keep in mind, if you're asked to do this on your exam, they'll give you a coordinate plane, which will be much neater than what I'm doing here, drawing a graph. I should have copied one for us, so this would be a little bit neater. But since I'm graphing linear inequalities, I don't need the same level of correctness that I needed when I was graphing the system of linear equations and was looking for an exact point where the two crossed. This time I'm looking to shade the region involved in each inequality. So remember that we have to, when we're graphing, we have to look at whether or not our lines are solid or broken, and that's determined by whether they're greater than or less than or greater and equal to or less than and equal to. Well, these both have an equal to, so these are both going to be solid lines. This one's solid too. And they're both greater than, so on both of them we're going to shade above. I'll let that above stand for both graphs. So on both of them I'm going to graph a solid line, and on both of them I'm going to shade above that solid line. So let's start with y is greater than or equal to x plus 2. Our starting point is always b, our y-intercept, so I put a dot at 2. And then my slope is 1 over 1, so I rise 1 and run 1, put a dot, rise 1 and run 1, put a dot, do it again. This is not going to be a real accurate line because my ticks are not perfectly evenly spaced, as you can see. Then I'm going to connect those lines, those dots I mean, with a solid line because we said our line had to be solid. And now I'm going to shade above it, which means I'm going to shade this way. Okay, now I'm going to go to graph my second line. My y-intercept is 5, so that's 1, 2, 3, 4, 5. Draw a dot. And now my slope is negative 1, so I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And it looks like I didn't do a real good job of my dots there, but let's pretend I did. Whoops, missed it altogether. Let me try that again. We'll pretend, okay, I did a really lousy job drawing that, but we're going to pretend that's a nice, perfectly straight line. You might have to use a little imagination there. But again, it's y is greater than or equal to negative x plus 5, so I'm going to shade above this line. And then what I'm looking for is where I overlap my two shading areas, which, as you can easily see, my overlap is right up here. And so I'm going to darken that area in a little more so it's really clear where my overlap is. If you just shade one, shade the other, sometimes hard to tell your overlap. So please, if you have to do one of these on the exam for me, make it really evident where your graph overlaps. And that's the solution. I don't have a point. The solution to a system of linear inequalities is a shaded area where the shading from the other two, or from the two, linear inequalities overlap each other.